Hey guys, what's up? It's me, Leaf from Coding with Leaf, and today we have a very special video. We're doing a full stack Ethereum development video. So that means we're going to be starting by writing smart contracts, we're going to be testing those smart contracts, and we're going to be deploying them, and then we're going to make an entire user interface for our users to interact with our smart contracts. This is going to be some great valuable information for you future blockchain developers, because you're going to learn and see all the concepts tie together, and you're just going to be very much more experienced after this video. So I really appreciate it if you guys could hit that like button. It means so much to me. It helps push this information out to other blockchain developers trying to learn this stuff. So it means so much to me if you could hit that like button, guys. And if you like blockchain development, please consider subscribing, because that's what we do here. And one more quick plug, guys. I want to help you guys out. There's an opportunity for you guys to earn up to 250 free Bitcoin just by using my link in the description down below and signing up for Blockfi. If you deposit up to $100 or more on the platform, you'll be eligible to earn that free Bitcoin. So thank you guys so much for watching. Also, check out that link, definitely. And let's get right into the coding. All right, so the only thing I did here was I installed Angular. So what I did was I did this line here, npm I at Angular-CLI. If you don't have Angular installed, Angular is what we're going to be doing in order to make our user interface. So once you have that installed, you can just do this, ng new, and then project name. In my case, I named it Decentralized Bank. And that's basically all I did. And then I'll make a new folder. So after we've installed and then ran our Angular project, the next thing we're going to do is we're going to install Hardhat. So let's do npx Hardhat. This is a framework for us to write and test easily smart contracts. Let's run that real quick. And we're going to have to wait for npm to install some of the packages, or just to fetch the npx command rather. And then we're going to be installing all the dependencies we need right after we do this line. All right, so let's create an empty hardhat.config.js file, and we're going to be starting from scratch, guys. All right, this is very important, guys. We have to do this line right here. We have to run. Let me just move my camera out of the way so you guys can see it more clearly. We have to run this npm install. This looks like a massive npm install, right, guys? It's npm install -- save dev hardhat Nomic Labs Hardhat Waffle, Ethereum Waffle, Chai, Nomic Labs Hardhat Ethers, and then Ethers. So these are all the dependencies we're going to need in order to write our smart contracts and deploy them and test them as well. All right, guys, while we're waiting for that, one thing that we can do is we can actually go to our tsconfig.json file, and we're going to add some code, add some lines here. What we're going to do is we're going to add the ability to resolve .json files. So all we need is resolve JSON module to true and ES module interrupt to true. And once we've saved that, we're going to be all set, and we can exit this JSON file. Great. We have all of our dependencies installed. So what we can do now is we can just install one more dependency. It's going to be npm install, or I, at openzeppelin /contracts. Guys, this line is going to install some smart contracts we need from OpenZeppelin. They're an open source kind of API if you'll have it. They just offer us some free smart contracts to make our life as a developer much easier. So instead of having to write an ERC20 smart contract to make ERC20 tokens, we can just inherit it, and we have to write nothing. So guys, now that we have everything installed, we're going to do a little bit more environment work. So we're going to first create a folder in the main path, and we're going to call it environment. There we go. Spelling is hard, guys. And inside environment, we're going to make a new file, and we're going to call it secrets.json. All right. The next thing we're going to do is we're going to create a new folder, and we're going to call it blockchain. In this folder, we're going to make 3 subfolders. We're going to make, inside of it, we're going to make contracts. We're going to make another folder called scripts. and we're going to make another folder, and we're going to call it test. Great. So these are the 3 main folders we're going to need in order to write our smart contracts, deploy them, and test them. Not in that order, of course. Write them, test them, and then deploy them. But that's not how it comes up in alphabetical order. All right, so let's go into our hardhat.config.ts, and this is going to be some of the last development environment things we have to do. We're going to do require at Nomic Labs Hardhat waffle. So this is going to give us the capability to use Hardhat waffle, which I'm not going to explain that right now, but just know we need it. The next thing we're going to do is I'm going to copy and paste some code here. Is we're going to do this instead of Solidity version 0.7.3, we're going to do 0.8.4. Then we're going to add a new object in here. We're going to add paths, and then we're going to route sources to blockchain/contracts. So we're going to say that our contracts are going to exist in this folder here. We're going to have our tests exist in this folder here. We're going to have our cache exist in a new folder we're going to create in the same blockchain folder. And then we're going to have our artifacts exist in this folder. And artifacts are basically going to be our JSON representations of our smart contracts. So when we export our smart contracts, they're going to come out in .json objects, and we're going to be able to work with them that. All right, great, guys. So now we just save that. The next thing we're going to do is we're going to copy and paste this line in. Networks. So networks is going to be where we store our network information. So when we actually go to deploy, I'm going to be deploying to Mumbai testnet. So we're going to find out the information from Mumbai testnet, and we're going to deploy to that. Right now, I put it as secret.mumbai node because in a second, we're going to require this line here. Const secret equals require. This is going to be blockchain. Or no, this is going to be environment secrets.json. This is the file we made here already. Inside our secrets.json, we're going to have a secrets key. We're going to have the Mumbai node key and the private key. And guys, if this is confusing you right now, don't be scared. Honestly, this is not the difficult part. We just need to get this environment stuff set up. Once you get through these simple steps, I'm going to tell you exactly what to do. You're going to actually be working on developing. So don't click off the video, guys. Just trust me on this one. You just need to get through this part, and then you'll be able to progress even further. All right, so what are we going to do? We're going to go to my favorite site to get a node from. That's going to be Moralis. So I'm going to go to it right now, moralis.io, and I'm going to bring my screen up here so you guys can see it. Now we're going to log in. I already have a login, but if you don't, you need to create your own. So we're going to go to Speedy Nodes, and it's free, by the way, to do this, guys. There's no necessary payments involved. We're going to go to Polygon. Polygon, you can deploy to Binance Smart Chain using this method. You can deploy to Ethereum mainnet or testnets, Arbitrum as well. But we're going to use Polygon. And guys, I'm blurring this because these are my private nodes. I don't want you guys to be able to see this. So basically what I'm going to do here is I'm going to find Mumbai testnet. I'm going to click this here. And guys, add this to MetaMask right now. If you don't have MetaMask installed right now, that's fine. I'm going to discuss it later. If you do have MetaMask installed, go to here, add to MetaMask, and then that's going to take out a step. But if you don't have MetaMask yet, we're going to talk about that in a second. So don't worry about that. I have this pasted here, and I'm going to go into here. I'm going to create a new object in my secrets.json, and I'm going to call Mumbai node, and I'm going to put quotes around it, of course, as you do in JSON. And I'm going to set it here to my private key. Great, guys. So once that's done, we're going to create a new one and call it private key. So this is going to be private key. And we're going to set this equal to our private key of the wallet we want to deploy with. Guys, I'm going to teach you how to do that right now, all right? So the first thing we need to do is we need to go over and get MetaMask installed. So you see this MetaMask up here? I have it right here. What you guys need to do is you need to go search up MetaMask extension and download the MetaMask extension and pin it to your Chrome bar or any Chromium browser. Once you have that, you're going to create an account, create a wallet on Ethereum mainnet probably, and then we're going to set up a Mumbai testnet. So what we're going to do is we're going to go back into Polygon Network. Once we have that done, I'm actually going to show you. So I've actually logged in. I have 3 accounts available here. This is my mainnet account, and then I have other accounts here. So we're going to go to here, custom RPC. We're going to click that, and then we're going to type in our network name, and then we're going to find the RPC URL, the chain ID, and optionally you can put in the currency symbol, MATIC, for the Mumbai testnet. If you don't know how to do that, you can Google it, or you can go onto Moralis, you can click Polygon, and then you can click add to MetaMask, and that'll automatically insert it with everything valid inside of it. Then we're going to select the Mumbai testnet, and then we're going to find our public key. That's our public key. And then we're also going to find our private key by going into account options, account details, then export private key. We have to type in our MetaMask password, confirm, and we're going to have our private key there. All right, guys, obviously I blurred my private key, but I just put that private key right here inside of this JSON object because I don't want you guys to be able to steal my account, of course. Blah, da, 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 da. All right. So now that we have all these environment variables set up, we have this set up to go to NumBuy. Of course, we gave it the URL of the node. We gave it in this accounts array. We passed it the account string. This is the private key of the account. We're going to be able to connect to the blockchain with this. And if you wanted to deploy to, say, Ethereum mainnet, you just say Ethereum. And then we just put the URL of an Ethereum mainnet node, and then we put an Ethereum private key. And then that's exactly how we would deploy to Ethereum. And I'm going to show you guys how to run the command later on when we finish testing and writing our smart contracts. All right, guys, now we're going to create some contracts. Let's actually start out by writing our first contract, bank.sol, and then we're also going to create a new contract as well called token.sol. And these are both Solidity files. Obviously, they're smart contract files. All right, guys, so we're going to start off with the bank, but we're actually going to be switching between the two contracts because they work together. They're going to coexist, so to say. So the first thing we're going to do in both contracts is declare that the version of Solidity being used is going to be 0.8.4. We're going to do the same thing here. In our bank contract, what we're going to do is we're going to import our token.sol file. And obviously it exists in the same folder, so we just do one./token.sol, and that's going to import the whole file. The next thing we're going to do is contract bank. And this is going to declare our smart contract called bank. All right, so the first state variable we're going to have is, and the only state variable we're going to have is accounts. It's going to be public, so we can read this on the blockchain, but this is just going to map an address, so a person's address, to a uint256, aka the amount of MATIC they currently have stored in our bank. So that's basically all this is going to be. Now the next thing we're going to do is we can just make a blank constructor just for this is because this is it's typical when making a smart contract. We just have a constructor and it's going to be blank. We're actually not going to put anything in it. So the first thing we're going to do is we're going to make this function here called total assets. And this is going to return the total amount of assets locked up at that current time in the bank. So say I give you the bank 10 MATIC, another user gives the bank 10 MATIC, and another user gives the bank 10 MATIC. The total assets is going to equal 30 MATIC. And that money is going to exist inside the smart contract. So we're not keeping track of that state variable. All we have to do is return address, cast this as an address dot balance, and that's going to return the balance of MATIC or Ether, depending on which network you're on, of the smart contract. Of course, and then we have these two modifiers here. We have view and we have public. So this can be read by anybody. Actually, we don't have to make this public. We can actually make this probably external. We can probably just do that external, which means that that the contract can't call this function, only it's public, but it's public to outside the contract. So, and then view means that this does not change the state of the smart contract. This doesn't change any variables. All it does is views the state of the contract. That saves on gas fees. Now, and it returns the uint256, of course, of the balance. Great. The next function we're going to need to do is deposit. This is going to be a function that allows us to deposit our MATIC into the bank. So function deposit is payable node is payable. That means we can send value to it, like we can send Matic or Ether to it, and it's going to be external as well. It can only be called from outside the contract. Now inside here, we're going to require that the amount sent message.value is greater than 0. So you must deposit more than 0 Matic. You can't deposit 0 Matic, it just doesn't work. Then we're going to plus equal message.sender the accounts. So remember how mappings work. It maps an address to a UIT. So if we pass it the address of message.sender, we plus equals the UIT of the amount stored in the contract. So this is going to be a value of Matic. So here, Matic, the amount of Matic we pay deposit function is going to be sent and recorded. Well, the Matic is going to be sent into the contract. The Matic exists in the contract, but we have to keep a record of how much Matic each person has deposited and not withdrawn. So we have an accurate record of that, and we can verify that. All right, so the next function we're going to need is the withdraw function. And this is going to be the last function that exists in our bank contract. So this is going to be a little bit more of a complex function. Guys, don't get confused here. I'm going to try to explain it the best I can. So just keep that in mind, all right? So function withdraw is going to, we're just going to pass it two values. An amount, that's the amount we're going to withdraw, and the address of the token contract, because we need to be able to move around the tokens when we withdraw. We're going to give the user a token when they withdraw. So this is also going to be external. Here we have this statement, require amount is less than or equal to accounts message.sender. So remember, this is going to return the amount the user has deposited. So we're making sure the amount that they're trying to withdraw is less than or equal to that. And then of course, cannot withdraw more than deposited. That's going to be the error message. Great. So accounts of message.sender is going to minus equal underscore account amount. So amount. So we're gonna subtract that from our state variable of accounts. Now we're going to cast message.sender as payable, so we can do .transfer the amount. So that is going to transfer from the smart contract, the amount of Matic or Ether into the user's account. Now we want to give them the token. So since we have this token.sol file imported here, we can run these two lines. But before we do that, I'm actually going to hop over to the token contract and write that. So here we have import Open Zeppelin contracts token ERC20 ERC20.sol. This is going to import the ERC20 token contract. Now we can use this as a standard. We barely have to write any code for this. Contract token is ERC20, and that automatically makes token inherited of ERC20. So now we're going to make a private address, and that's going to be called the bank contract. So this is going to be the address of the bank contract, because only the bank is going to be able to mint these tokens for users. So we're going to make a modifier here. It's going to be a modifier for a function that we see in the future. It's going to be only bank, and it's going to require that the message.sender is equal to the bank contract. So only the bank can mint new tokens, and then obviously we have this little line here that just ends the modifier. So in the constructor, here's what we're going to do. The constructor has two parts to it. So the first thing we're going to do is we're going to pass the address of the bank address contract. When it gets deployed to the blockchain, we're going to pass the address of that exact smart contract to this contract. That's how we can get them to work between each other, because they know exactly what the code of the smart contract is and exactly the address of where the smart contract is deployed to. So don't get too confused if you don't fully understand that. You will in the future, I promise. It's a very important concept when it comes to Ethereum blockchain development, smart contracts in general, is being able to work between the two smart contracts. So the next thing is we call the super of the ERC20 constructor. We pass it the name of the token. It's going to be called yield token, and the ticker symbol is going to be free. Great. So then we set the bank contract equal to the bank address, of course. Now the only function we need to have in here is called mint. So it's going to mint address to and the amount and then only the bank contract can actually call this function, guys. If anybody except the bank contract tries to call this function, it's going to get reverted. The transaction is going to get reverted. And then we call the function inside the ERC20 contract. This isn't super complicated. This is just a function that exists inside the ERC20 smart contract already that just mints tokens to an address for an amount, and obviously it's going to be the same variables that we passed in here. Great, so that is the token contract, and that's all we have for the token contract, guys. Now that we have this written, this makes a little bit more sense. We declare a variable yield token as a token contract, and then we're going to pass it the address of a token contract. This is the syntax to actually make a reference to another smart contract in Solidity. We do this: token yield token equals token, and then we call the address of the token. Then we're going to do yield token dot mint. Of course, that's the function that we declared in our token.ssy that actually mints it, and then we're going to pass it the message.sender and 1 ether. All right, guys. If you don't fully understand those concepts, please rewatch the video. Please go learn a little bit more about Solidity. It's only going to help you. It's only going to help you. It's really important that you guys understand these concepts, because this is basically what smart contract development is. And if this stuff made you lost, then you guys got to learn this if you want to become blockchain developers. Guys, it's really not super difficult, but that's just, these are just the steps you're going to have to take and sacrifice your time in order to become a blockchain developer. Great. We have our smart contracts written, guys. We don't have to do any more smart contract writing for this entire video. Now we're going to test our smart contracts. I'm going to show you guys how we can actually test our smart contracts using the Chai framework. So we're going to head over to test, and we're going to make a new file, and we're going to call it testbank.js. And it's going to be a JavaScript file, guys. So the first thing we're going to do is we're going to import expect from Chai. So now we have this this use case here, expect, and I'm going to show you the basics on how we actually test our contracts. So we describe something, and this is kind of like the owner of. This is kind of like a class when we're testing with the Chai and Mocha framework. So we're going to declare some state variables here. This will all make sense in a second. And then we're going to declare another state variable here, let addresses. Cool. So we're going to have this function here called before each. So this is before every single test, we're going to run this function. It has to be asynchronous because we use the await keyword. So what we're going to do inside here is we're going to create this bank contract. This bank contract is going to equal await ethers.getContractFactory, and then we're going to find the bank contract. So what is this going to do? Well, when we compile our JavaScript smart contracts, they're going to go into this thing called artifacts, and Hardhat, the framework, is going to be able to find that artifact and then get the contract factory, which is basically a JavaScript representation, kind of, and then set that to bank contract. Then we can call functions on bank contract that allow us to deploy it to the network or whatever. So when we're using our test files, it deploys to a local blockchain. So it's not going to be deploying to mainnet, it's just going to be deploying to local and testing them on local. So bank, in this stake variable right here, bank equals await bank contract.deploy. And then we're going to await bank.deploy. So these are just the basic syntax for us to deploy a contract to the network. And remember, we need to deploy our bank contract before we deploy our token contract, because we need to have the address of the bank contract and put that into our token contract. So now we have token contract equals await ethers.getContractFactory, token this time. Now we're going to let token equal await token contract.deploy, and then we're going to pass it the address of bank. So remember, bank is the actual JavaScript object that is the deployed smart contract on our local blockchain. So we just call bank.address. It is a state variable in bank, and then we're going to await token.deployed. So now we're going to set these variables equal to ethers.getSigners. So we're going to be using owner, address 1, address 2. These are all addresses that exist on our local blockchain, and we're going to need them for testing because we want to do some stuff between the two of them. So we're going to have these right now. We're going to have these next describes. So describe deployment. So we're just going to test out, make sure everything's going well with our deployment. So it should have assets of 0. This is the syntax for Mocha and Chai. So we basically, it kind of reads like English. The it function tests a certain thing. And then in it always has an expect inside it. Expect is a statement that expects either a true or false Boolean, and then yeah, that's basically how it works. So we just test that this value is equal to this value, or test that this state is equal to this state, testing everything that we think matters inside the smart contract to make sure everything's working the exact way we intended it. That's what testing is, guys, because we can only deploy it one time to mainnet, so we want to make sure it's perfect. So we make an async anonymous function here and expect await bank.total assets. Guys, whenever we make a call to a smart contract, it has to be asynchronous. That means there's time between when you call the function and the response from the blockchain, and then we get that answer back. So we have to use async await hook here. And if you don't fully understand that, go learn about promises and then go learn about async await in JavaScript and TypeScript. This is a very integral part of blockchain development because everything is asynchronous. We have to go make a call to the blockchain, and we have to get that call and wait for it. So we await bank.total assets, and then we call to.equal 0 because the total assets of the bank should be 0. We haven't put anything in it. So it should have 0 tokens and 0 deposit in owner account. Expect await bank.accounts owner address to equal 0, of course, and then we have expect await token.balance of owner address to equal 0. Remember, this is a function that actually exists in the ERC20 contract. We didn't declare this, but it exists because it's an ERC20 token. So we can check the balance of a specific address, and it's going to return the balance. So it should have 0 tokens and 0 deposit in address 1's account, and the same thing for address 2 account. All right, guys, let's run this test real quick to make sure everything is working smoothly. I'm actually going to bring my terminal over to this side so you guys can see it a little easier. I'm sorry, guys. I made a crucial error. I was trying to debug this code. I realized I put my contracts in the script folder. That was really dumb of me. Don't make the same mistake that I did. Sorry if you guys spotted this mistake before me. That's a little annoying. Sorry about that, guys. Again, that was definitely unintended. I was wondering why nothing was compiling. Great. Now things should be compiling as normal, so we can actually run this script. So mpx hardhat compile. Sorry about that, guys. And this is going to compile. And now we have our artifacts here. You see these artifacts? These are our in our blockchain. We have bank.sol and token.sol. And now we can run npx hardhat test. All right, guys. All of our tests actually passed. This is exciting. So obviously I expected them all to pass, but you know, it is always exciting when we have our tests pass, of course, guys. So awesome. Now these tests work. So let's do some more testing. I'm going to move my camera back over here, and we are going to continue with the development. Now, the next thing we're going to do is another describe, and this is going to be a massive block I copy and paste, guys, but don't get too overwhelmed. 1 second. We're just going to walk it through. So test, we're going to next test the deposit and withdrawal. So we're going to set this const here 1 ETH equals to ethers.utils.parseEther1. This is a utility function inside of Ethers.js, which is a Web3 library. Basically, this just allows us to get Ether and Matic are all split into a ton of decimals after them. So if we want to work with numbers in human readable forms, we're going to need to use this utility function in order to read it. So this variable just has the value of 1 Ether, and we're just going to be using this 1 Ether because our token actually has the same amount of decimals after it as an Ether does. So 1 token actually is the same number as 1 Ether or 1 Matic because they all have the same amount of decimals after them. Great. So it should let owner deposit 1 Ether, then total assets should be 1 Ether, and accounts owner should be 1 Ether. And then we're going to have an asynchronous function here. So basically, this is the life cycle of depositing. We're going to await bank.connect owner.deposit and then value 1 Ether. So what is this exactly doing here? Well, basically, we are just connecting this function allows us to switch the address that's making calls to this contract to another address. So we're setting the person that's making calls to the bank contract to be the owner wallet address, because the owner wallet address is the one that's actually depositing. So he's going to deposit the value of 1 Ether. We have this variable here. So we're going to expect that await bank.totalassets equals 1 Ether, of course. And we're going to expect that bank.accounts owner.address is equal to 1 Ether. Great. So this should all be self-explanatory. This is what we expect. So it should let account 1 deposit and withdraw 1 Ether, then have 1 free token as well, because remember, we're giving it free tokens. So I'm just going to put this here so you guys can see it through my camera. Just want to make sure everything is readable. 1 second. This should be okay for you guys. You should be able to see most of it. So it should, of course, so await bank.connect address 1, and then we're going to deposit 1 Ether. Then we're going to immediately after we deposit it, withdraw that 1 Ether as well. So we're going to connect bank.connect address 1, and then withdraw 1 ETH. And then we're going to pass it, of course, we need to pass the token address. So that's going to be the address of the token smart contract. Now we expect bank.totalassets to equal 0, and we expect token.balance of address 1.address to equal 1 ETH. So this is just, we pass it the address of address 1, and then that token balance should also equal 1 ETH as well. The last thing we're going to do, it should fail when trying to withdraw money you haven't deposited. So what we're going to do is await expect bank.connect address 2 to withdraw 1 ETH, and obviously we pass the token address, to be reverted with, and then the error message. And guys, this should not work because we've never deposited the 1 ETH into the account. So how can we withdraw it, right? That would be a crucial bug in our bank contract if you could withdraw money you haven't deposited. So we want to make sure this reverts, and reverts for the reason that you cannot withdraw more than deposited. That's the reason we gave it earlier. So I'm going to save this contract right now, and we're going to go back into our terminal, and we're going to do npx. Oh, I'm going to move my head over here, and then we're going to do npx hardhat test, and this is another this is something we can do, and let us check to make sure everything worked out well. So it did, and all of our tests returned positive, and they all passed the exact way we thought they would. So guys, remember, actually this is fun. It's the millisecond timing between for the test, and they alert you when something is kind of slow. So obviously it's going to be slow when we try to withdraw and deposit function Ether or Matic on the network, because obviously it takes time to do that. So guys, this is pretty much what we need to do. This is testing. This is becoming a smart contract developer. We need to test our smart contracts as we write them, because this will show us the bugs that exist in the contract. Now that we kind of understand testing, if you don't fully understand testing, that's okay. We can continue on to actually deploying our smart contracts. So after we do that, the next thing we are obviously going to do is we're going to deploy our smart contracts onto the Mumbai testnet. And what are we going to need to do that? Well, we need to write our script. We need to write our script that actually deploys it to the network. So let's go over to our script and create a new one, new file, and then we're going to call it deploy.js. And this is the script we need to write in order to deploy to Mumbai testnet. So we're going to import file. We're going to import being able to make JSON just because of something we're going to do in the future. You'll see why, but just import this for now. The next thing we're going to do is we're going to make a asynchronous function, and we're going to call it main. And main is going to be called right under it, right under the function. We're just going to call it. It's a script that just runs, and then we're going to call main, and then when it's done, it's an asynchronous function, so it returns a promise. If you don't fully understand that, of course, go learn about promises and asynchronous functions. You need to know that, not just for web development, but also, more importantly, blockchain development. It's necessary to know. Process.exit, we're just going to exit the program after everything is deployed. So what are we actually going to do inside here? Well, we are going to deploy our smart contracts to mainnet. or actually testnet, Mumbai testnet, more specifically. So right here, we're going to copy and paste this block of code. Bank contract equals await Ethers.getContractFactory bank. We actually already did this one. This is just something that exists because we have all of our pathing for our artifacts set up in our hardhat.config.js. We have the pathing of our artifacts, so it knows where to look, and we can just search by string, bank. And then we're going to wait on it to be deployed. And then we're going to log to the console. The bank contract was deployed to bank.address, and we're going to deploy, and we're going to log the address of our bank on Mumbai testnet. The next thing we're going to do, obviously, is going to deploy our token contract. So token contract equals await Ethers get contract factory, same thing. And this time the only difference is we're passing the bank address like we did last time into the token contract. Now we're going to print where the contract was deployed to. So we have some little bit of verification, a little bit of validation. Now the last thing we're going to do is we're actually going to create a JSON file. And you guys can copy this word for word or line for line. Just know that all this is doing is it is making a JSON file, and we're putting it in our environment folder. We're going to put it in environment contract addresses.json. We want to have the locations of our contracts in the future. And if we were to keep testing and deploying our smart contracts, it would get really annoying if we had to keep copying and pasting the address over and over and over again into our front end. So basically all we're going to do here is just make a file that rewrites every single time and just puts our contract addresses into a file. And that's pretty simple. If you've ever used files in JavaScript before, you've actually already used this function. So I don't really have to explain it to you if you know JavaScript pretty well. What are we going to do now? Well, we're going to deploy it. I'm going to move my camera over here so you guys can see more clearly that we are going to run npx hardhat run, and then we're going to go into we're actually going to go into blockchain. Obviously this is our file system. We're going to go into blockchain, and then we're going to find our scripts and then deploy.js /scripts/deploy.js, and then we have to specify the network that we're going to deploy these smart contracts to. So -- network, and then we're going to choose to go to Mumbai. Remember, we declared that earlier with the URL and the private key. Great, let's run it. Now is what's going to happen. Well, we have to wait for our smart contract block to get mined, but it looks like this one did. Okay, it's already deployed. The bank contract was deployed here, and the token contract was deployed here. And what happened in our file system? Well, of course, here we have contract addresses, and now this returns the address of the token and bank contract, and we have that information available to us when we write our front end code. All right, guys, now this is the last part, and we are actually going to be making a very simple UI for this. It's not going to be complicated whatsoever. So now UI is actually not my strong suit. I'm actually not very good at writing front end code, and you guys are going to see that this UI is going to be extremely ugly, and that's okay. We're going to be okay with that. All right, let's go into our source file, and we're just going to go into our app, and we're just going to use one page. We're not going to do any routing. And again, guys, we're using Angular for this. If you're not familiar with Angular, if you've used React in the past, Angular is just another UI framework. I'm sure you guys have heard of it before in your life, but it's just a UI framework. It helps us build better user interfaces. At least that's the hope. If you ask a lot of people, they'll tell you that Angular helps you build more complex and confusing to develop user interfaces, and React is the way to make nice user interfaces. But you know, that's just opinions, so don't get too caught up in that. So we're going to import reactive forms module and the forms module as well. And we're actually going to go into here and into our imports, and we're going to import that as well. So now we have reactive forms module and the forms module. So that's pretty easy. The next thing we're going to do is go into our app.component.ts, and we are going to set up everything. So we actually don't need this anymore. That's kind of garbage. And there's a few things we're going to have to import, guys. We're going to have to import ethers. We're going to have to declare this variable here. I'll explain this. I don't really need to explain this. Just put this line here, guys. This is needed because of something we're going to do with window.ethereum. Just Just you don't have to know exactly why this is in here. It's fairly technical. In the future, when you're writing JavaScript, you actually won't need to specify this, but since it's TypeScript, there's some weird little intricacies that we have to just work around. Okay, guys? And then the next thing we're going to do is we're going to import our form controls and our form group. These are from Angular. And then we're going to import our addresses and our bank JSON objects. So obviously we import addresses from, actually this here is going to be blockchain. And this is going to be blockchain as well. All right, so here we have our addresses, of course, from contract address.json. That's the file we generated automatically. And then we have our bank. We have our bank.json object. And then we have our token.json object that we found in our artifacts, blockchain contracts, token.swl, and token.json. So these JSON objects are important because we can get the ABI. So what is the ABI? Well, the ABI is a JSON representation of the smart contract. So we need the ABI in order to tell our API. I'm throwing around so many technical words right now, guys. I'm sorry if you're confused, but we need to make sure Ethers knows how to interact with the smart contract. And that's the way we do it, through a .json object. All right, guys. So we're going to need some state variables here. The first thing we're going to do is we're going to make some state variables of forms. So we're going to initialize these in the constructor, of course, when we write the constructor. Actually, let's just do that now. You don't have to get too caught up with this. This is actually just Angular syntax. So if you're not going to be using Angular in the future, you don't have to know this really that well. But for this project, you do have to do this because this is what we're going to be doing for our forms. So this is the best option to use forms in Angular. The next thing we're going to do is, note that we have our public signer variable here. Signer is going to be used for the address that is signing, or the the difference between a provider and a signer in Ethers. It's going to be something we might not talk about in this video, but just know that exists. A provider and a signer are not the same thing. But I'll show you guys. I'm sorry this can be so confusing because there's so much you guys have to know in order for this full stack development to work. It's really hard to explain it in super simple terms, guys, but I'm going to try my best. Now, we have our token contract and our bank contract, of course. And then we have our user total assets, user totals tokens, the total assets of the bank, and then the signer address. These are all state variables we need in order to interact with it. So we're going to actually, here we have to write implements ng, or actually on init. This is a Angular thing. Here we actually have to import on init from Angular. So in angular.core with component, we're going to import ng on init, and then we're going to make this async function here, asynchronous function. It's going to be called ng async ng on init, and it's going to take no parameters, of course, and then we're going to do that. So, all right, guys, now we are finally interacting with our user interface. So ng on init is an Angular function. When the page gets initialized, this function gets called. So that's just a little bit of Angular knowledge. So here is the next line of code, guys. We need to set a provider. So const provider equals new ethers.providers, web3 provider, and then we're inside here, we're passing window.ethereum and giving it this typing of any. Don't focus too much on this code right now, guys. It might be a little confusing, but just know in the future you will understand it a little bit better. And provider on is a function that exists to check if the network is a new network or an old network. If the user switches between networks, basically what we're going to do, if old network, well, just know that this code basically reloads the page whenever the user switches network. So we don't want the user to be able to interact with our page if they're just using any blockchain network. We only want them to interact with our page if they're using Mumbai testnet. So we're going to set in an error message for them if they are connected to any other network besides Mumbai. So I got the chain ID of Mumbai. If you want to get this information, it's all public. Every blockchain has its own chain ID. And we're just making sure that this .signer well, actually we need a clear signer here. This .signer equals provider.getSigner. This is a function that gets the signer object of a provider. Sorry guys, this is really confusing. I just realized that if you don't know about full stack, blockchain development, this can get really confusing, because the difference between a provider and a signer is this. A provider is just something that can interact with the blockchain. It's just something that can do read-only actions on the blockchain. So think of a provider as a thing that can read the blockchain, but it can't change the state of it because it's not an address. A signer is an address. A signer can be a contract, it can be a wallet, it can be anything like that that can actually make changes to the state of the blockchain. So that's why we need a signer object here. Since our provider is a user, it's our user wallet that's actually interacting with the site, we can get the .getSigner method and activate the signer. Then we can check what chain ID the signer is connected to, and if that's 80001, then that's the chain ID of Mumbai testnet. That's all available information on the public. And then we're going to set this alert. Please change your network to Mumbai testnet, because they are not connected to Mumbai testnet. So the next thing we're going to do is we are going to set this bank contract and this token contract equal to an ethers.contract object. So ethers.contract is a function that allows us to create a contract using the address of a contract, an ABI of that contract, and a provider or a signer. So we're using the signer of the user wallet that we've declared here. We have the ABI, the JavaScript representation of our smart contract, imported up here, of course. And then we have the address of the bank contract located on the blockchain in our addresses JSON file here. Same with the token contract. We need to get the address of the token contract on the blockchain. We need to get the ABI, so the function knows how to interact with it. And then we need to get a signer that's actually interacting with it. All right, guys. So that is one of the more confusing topics in blockchain development, is actually interacting with the blockchain through JavaScript. If you can master how to get that done, then you're going to be in a really good spot for learning this content. All right, guys, the next thing we're going to be doing is we're going to be setting the state variables. So, guys, I know this might look confusing. I know that this line right here might look, these lines right here might look confusing, but we're going to talk through them step by step. This user total assets equals, this is the total assets that the user has. Ethers.utils.format ether. So this is going to convert a big hexadecimal number that is equal to an ether. So that's going to be a 1 with 18 zeros attached onto it. That's what an ether is, or a matic, or a token. And then we're going to format this way. We're going to format it into a string that is human readable. So it'll take 1 with 18 decimal places after it, and then we'll turn it into 1.0. Okay? That's all this function does. We're going to await, of course, we need to await it because it's interacting with the blockchain. This .bank contract .accounts. This is the function inside the bank contract. Accounts, this is a public state variable inside bank contract. Of course, we're actually going to pull this up so you guys can see it a little more clearly. Remember, accounts is a public state variable here. And the way we interact with a mapping is we pass it, just like we would a function, we pass it the address, and we're going to do await this.signer.getAddress. And that's going to return, this, the amount of users' assets. Now this .total assets equals ethers.utils.format ether. Of course, same thing. And this time we're going to await this .bank contract.total assets. And this is the function in the bank that allows us to return the total assets. Now the next thing we're going to do is user total token equals ethers.utils.format ether. And then we're going to run the token contract. We're going to run balance of the token contract. And this is actually, again, a function inside ERC20. We didn't write this function. It just came with us in ERC20. And then we're going to await this.signer.getAddress. All right, great, guys. Now, the last thing we're going to do is set the signer address to this.signer.getAddress. All right, guys, we finished our ng-on-init function. And if you are lost, it is okay, guys. If you are mentally exhausted, take a quick break, take a refresher, come back to this in a little bit. But you do got to finish this video out because we gotta actually get this done. All right, guys, the next thing we're going to do is we're going to do an asynchronous deposit function. So async deposit is going to interact. You know what? Before we do that, let's actually write here. I'm going to delete this real quick. Before we do that, let's actually write the HTML. So let's head over here. I just want to make sure you guys see what I'm seeing and my camera's not blocking in 1 second. Okay, great. This is actually perfect. So we're going to save this. We're going to exit out of this and we're going to go over to our HTML. And we're going to delete this HTML file. I accidentally did not delete that. Okay, cool. So we deleted that. Okay, awesome. Now our HTML file is completely blank. And let's actually go into our CSS. Our CSS is also completely blank, just so you guys can see it. So what are we going to do now? Well, we're actually going to write our front end. So I'm going to copy and paste a good amount of this from my notes here. Oh, this is CSS file, not an HTML file. Okay, so this is going to be the header, and it's going to say, welcome to the Decentralized Bank. Now we're going to have like a little label here. If this.signer does not exist, it means that you have not connected. So we're going to say that. You have not connected. Your wallet is not connected to our address or to our website. If it is, if this is all syntax for Angular, then you have connected. Now we're going to write a few bits of logging our states pretty much to the user. So we're going to log the total assets, the bank's total assets under management, and we're going to do this.total_asset-matic. Then the total free the user has. So this is going to be the amount of yield tokens that the address, we're going to log the address, and then amount deposited, user total assets. And then we're going to do the total, this is going to be the amount of matic that they currently have deposited. I use the same CSS styling, that's why I had it here. That's not as descriptive as it should be, guys. Sorry about that. This is going to be the amount of yield token free that they have. Free that they have here. So once all that is logged, we are going to set up a div with some forms in it, and we're going to label it. This is going to be the class forms. So inside here, we are going to have a form group, as we called it earlier. It's going to be called deposit form. This is going to be the form that actually takes care of the depositing transaction. So inside here we have a label amount to deposit, and then inside we also have an input of type number, and it's going to be the deposit amount. And then we have a button to submit the deposit. This is all Angular syntax, and we're actually going to hop back over to our app.component. And we are actually, before we do that, let's talk about our withdraw. Our withdraw is going to do the exact same thing, where we just pass in an amount here in this input field, and we just tap the submit button or the withdraw button, and that's going to send it the amount that we put in. So let's actually take care of the ng-on-submit logic here of these two functions. Now, first we're going to do deposit. Asynchronous function deposit is in our app.component.ts, and this is going to create a transaction. So const transaction equals await this.bank contract.deposit. We're calling the function of the bank contract. We're going to pass it the value, but parsed in Ether, of this.deposit form.value.deposit amount.toString. So guys, what's happening here is we're taking the number that the user inputs in this input field, and we're turning it into a string, and we're passing that as the value. And then we're doing transaction.wait, and that is a asynchronous function. Yep, and yeah, so that all works out. Actually, it's going to be await or wait transaction.wait. So that's going to be the function, and then we're going to wait for the transaction to be done. And then we're going to reset the form and reload the page. Now it's going to be very similar to what we do in the withdraw function here. We're going to, again, we're going to const transaction equals await bank.contract, except this time we have to pass it the address of the token contract second, but first we have to do parse ether of the amount. And then we're going to wait the transaction, and then we're going to reset and reload the page. Guys, we're getting so close to being done with this. I'm very excited for you guys to see the final project. So let us, first of all, go over to our, so the app is actually completely coded now, guys. Besides the CSS, we're actually just going to copy and paste the CSS in here. Basically what I did was just really simple styling just to format it right. We just have the header here. If you want to like look at this code real quick, the header has some styling on it. The connect button has some styling on it. That's just a label. This project has been through a little bit of iterations. The total assets, the total free, the forms are display flex, of course, and then we have forms of deposit, just padding for both of them. This is not very efficient CSS, guys. I'm not really great at CSS and HTML, to be honest, but it gets the job done. So now everything's working perfectly, guys. Let me just make sure everything is looking good. Okay, it is. We are going to ng serve, and this is going to run a local version of our project, our HTML and JavaScript project. Once it builds, we're going to be able to go find localhost 4200, and we're going to click that, open that up, and then we're going to make sure that we're connected. We are using account 2 on the Mumbai testnet. If you don't have any testnet Matic, go to a Mumbai testnet faucet and request some. So we have this, great. And what we're going to do here is we're going to actually deposit. So we have our Decentralized Bank, we have our U of Connected. Let's see what happens actually if we try to switch to Ethereum mainnet. We get a error alert. Please change your network to Mumbai testnet, because it's not going to work. Nothing's going to work here because we have to be connected because this is the provider. So let's go back over to Mumbai testnet. So we have our account here, of course, and we're going to owners total assets under management. Of course, the bank's total assets is 0 Matic, and then we have the amount deposited 0.0 Matic, and then we have this user's, this address's amount of yield token 0 free. So let's test the app out. Let's go let's deposit 1 Matic. Actually, let's deposit 0.6 Matic. All right, guys, deposit, and we're gonna get this little MetaMask thing. It's great. It's super fun. So what this is going to do is verify that we want to make this transaction. So basically it's going to cost us this much gas, and we're going to deposit 0.6 into the network. So we're going to confirm. We're going to wait for the transaction to be mined, and once it's mined, the page is going to reload, and we're actually going to reload it again. It might take a second for everything to work. Okay, great. So it does take a second to read the state of the blockchain again. And now the bank's total assets under management is going to be 0.6 Matic. And the user's amount deposited is going to be 0.6 Matic. Now let's try to withdraw our 0.6 Matic. Now we're going to get another thing, and we're going to have to pay this amount of gas. Let's confirm. And this is going to cost a little more gas. You know why, guys? Because we're actually minting a new token. And that is going to call extra functions. So the more functions we call, it's going to cost more gas, right, guys? So this also just got confirmed. It took a little bit longer to mine, but it just got confirmed, and we're going to reload the page. And now the amount of yield token we have is 1 free. So we have 1 yield token now. Isn't that cool, guys? Our application worked exactly as intended. And guys, this was a full stack development tutorial. If you enjoyed this, please hit that like button, guys. It means so much to me. And again, description down below, Blockfi. Get your free up to $250 worth of Bitcoin using my link in the description below. Get that free Bitcoin right now. Sign up for Blockfi, start an account, and deposit $100 or more into it. It's just free money, guys. Definitely check that out. And if you want to subscribe to the channel, it would be very greatly appreciated. We do blockchain content all the time. We're getting into even more interesting blockchain content like this type of full stack tutorial. We're going to be doing even more in the future. So thanks guys so much for watching. Hope you guys have a great rest of your day.